Hi, everyone, and welcome to the Global XR Bootcamp. More specifically, to my talk about Project Northstar and getting started with open source augmented reality. I'll start with a little bit of an introduction of myself, walk you through the history of Project Northstar, some of the roadmap and exciting developments we've been working on to make the project more accessible and user-friendly. This talk is going to be a general overview of the headset, so if you're looking for something more software-based, definitely check out Damien Rompas's talk on Project Esky, which is a Unity and upcoming Unreal project that will work directly with Project Northstar and other headsets of this nature. So that'll be really cool. Definitely check that out. So my name is Brian Chris Brown. I have a background in architecture and environmental design. I got a degree at Morgan State University in 2017. I currently work at a company called Hyrox Studios as a 3D and XR artist, where I create everything from interactive walkthroughs of buildings, interactive AR, exhibits for museums, 3D renderings, sort of like Pixar style. So that's the ones where you have to wait for the computer rather than just having 60 frames displayed in a second. So I definitely have a preference for real time. I've been using Unreal Engine for about 4 to 5 years now. And 3D for much longer than that. So that's sort of my background. I started on Project Northstar in 2018, shortly after Leap Motion released the original open source files. And ever since then, I've been helping people out on the Discord and really managing the community aspect of Project Northstar and sort of connecting people where they need to be connected and leading some of the software projects like the Steam VR drivers, some help with calibration methods and things like that to make the project overall easier for people to get started in. So if you haven't heard of Project Northstar before, it's an open source augmented reality headset that boasts 110-degree horizontal field of view by 70-ish degrees vertical. It looks like this. So this is the current iteration of the Project Northstar headset. This is the Deck X variant by Combined Reality. So you can see there's a few things going on with it. So first is this lid up here. So this houses an integrated T261 sensor from Intel RealSense. So that's what currently allows us to do 6 degrees of freedom tracking, anything with image tracking, things like that. And then we've also got a Leap Motion controller. So the Leap Motion controller provides super high quality hand tracking, and it's a really great method of interaction that you don't need controllers for, which is pretty great. So right now, all of the tracking for everything in this headset is on board the headset. So there's no lighthouses, there's no extra controllers that you need. It's all put on the headset, and everything you need to interact with your augmented reality experience is right there, directly embedded into the headset, which is pretty cool. So just to go over some more specs, so there are dual 1440 by 1600 pixel panels on this headset. So they're the same ones used in the Valve Index, and you can see that they're located to the side of the eye rather than in front of it. So the way that works is with a parabolic reflector. So these two reflectors here, so this is actually a single piece now, so it's fully injection molded single piece, which works great for assembly, makes it much easier to calibrate the headset. And so the light bounces from the screens onto the reflectors and then back to your eye. And there are a few advantages to this method over waveguides and things like that. So first is cost. This is much lower cost than something like a HoloLens or Magic Leap. It's easier for people to build. So if I were to put a build guide together for a HoloLens 2 or Magic Leap, those are very complex devices that require lab environments to build in, since the pieces are so small and so intricate. So there probably won't ever be a build your own HoloLens, but there is a build your own Northstar. So because this uses relatively off-the-shelf parts with a few custom pieces like the display driver board and everything like that, this is actually a pretty, I'm not going to say easy because nothing is ever easy, right? You ever tell yourself something easy and you start it and you're like, oh man, that's not easy. It's because you're learning. So nothing's ever easy, but we definitely will help you along the way. but it's definitely a much more straightforward build process. And because it uses, the same relative hardware as open source, or not, sorry, the same relative hardware as VR headsets, we can actually leverage some of the economy of scale that there and get the parts down to cheaper prices. And you may have noticed that this headset is actually completely 3D printed. So that's one of the other cool things about Northstar that I've somehow forgotten to mention so far, is that the headset is 3D printable. So you don't need to have access to an injection mold factory or buy injection molded parts from us. If you want to build it yourself, there are plenty of affordable 3D printer options out there, or you can go to your public library or makerspace once they start opening again, of course, and get the headset printed. We've made the parts much simpler to print than when the original open source files came out. So it should be much more straightforward then. And we've got a full build guide as well to walk you through all of that. And I'll put the headset a bit closer here so you can actually see some of the layer lines. So this is my custom prototype of DeckX here. I did some dremeling on it earlier. So that's why you see some, namely this that I just pointed directly at the camera. So don't worry about that. That's my. So the FOV of the headset is roughly double that of the Magic Leap 1 or HoloLens 2 devices. The resolution is incredibly high, since essentially there's no screen door effect, right? Because you're not amplifying the image from the screens, you're just reflecting it. So it's actually a super high quality image. And because the displays get so bright, you can actually use this for VR in some dark environments, though AR is definitely where it shines. So the headset is currently available from smartprototyping.com in the form of build-it-yourself kit. So that'll come with all the hardware, electronics, screws, heat set inserts, all that kind of stuff that you need, even cables that you need to get started with it. The only thing you'll have to do is source the 3D printed parts, which you could either get a 3D printer yourself. The Discord community currently recommends the Ender 3 from Creality. It's around $200, $180, depending on where you can find it. And it's a great starting printer for such a low price. So it's definitely easier to get in now. Plus, you can 3D print whatever you want, which is great. So first up, I wanted to discuss the timeline of events since the project started, and also get into a bit of roadmap stuff for software and hardware. So you can see from the diagram here, the project started, as I mentioned before, in 2018 or so. Immediately after that, there were a few offshoots, namely the XE Raspberry Pi headset that used two 3.5-inch Raspberry Pi displays and some 3D printed reflectors for the headset. So this was done because access to the hardware wasn't really a thing yet. So it was really cool to see people hacking on it. And in fact, one of my first Northstar headsets was actually a Windows Samsung Odyssey headset that I had disassembled and rebuilt into a Northstar headset because the displays weren't quite available yet. So that was a pretty fun little project. So then shortly after that, Noah Zirkin and Smart Prototyping came through and were able to source the reference displays that Leap Motion requested, which were the BOE 3.5-inch 1440 by 1600 displays used in the Valve Index. They were also able to manufacture the driver board, manufacture the lenses, and there were a few different revisions the lenses went through. And in the community, we use the term lenses and reflectors sort of interchangeably. So the technically correct term is reflectors, but lenses in this case are also fine. It gets the idea across. So the reflectors went through a few different revisions to test different coating styles. And then eventually, once we got the coatings figured out, we ended up on a single piece combiner or single piece reflector that allows the assembly of the headset to be much more streamlined. So previously with the single piece reflectors, it was common that the alignment of them could be a bit off. And with them as a single injection molded piece, it makes the alignment of the headset much more standardized. So that was a really big innovation. So recently, and I guess it's not so recent anymore, but last year we were able to attend MIT's Reality Hack and actually demo some Northstar headsets to the teams there, right next to Magic Leap and HoloLens 2. And all of the devs we got to show the device to absolutely loved it. It was a great opportunity to really show the headset off to hundreds of devs. So it was definitely a really cool event. And from there, we got a lot more people in the community, and we've started streamlining a lot of software. So we've rebuilt the Steam VR driver from scratch. Project Esky is really shaping up to be a great underlying um, infrastructure for a headset that is cross-platform and can really provide a unified development layer um, between the Northstar hardware and things like Unity, Unreal, and eventually we're actually going to integrate it into Steam VR as well. Um, so that'll make development a lot easier, more straightforward, and it'll all be unified, which will be great. And then the other exciting development we're working on is 2D calibration. Now, this is a new calibration method that uses a single stereo camera to figure out the UV and the UV distortion of the parabolic reflector. So essentially, it means you'll get a correct image from just a single stereo camera. Um, Prior to this method, we've had to use two stereo cameras. So essentially, what it means for you as an end user is that you will not have to buy another stereo camera. You can just use the one you get for your headset, whether that be an Intel T261, the upcoming Oak D from Luxonis, um, or the Z Mini. And we can add support for any stereo camera relatively easily. So if you want to use a different one, just ping us on the Discord and we can talk about adding that in. So that's some very exciting developments. So next we'll be moving on to some of the just general software timelines. So the project initially started out with a pretty bare bones Unity SDK. Um, so we worked with that a bit, and then we added Steam VR support as an initial pass. Unfortunately, that was broken within a Steam VR update, so we had to sort of go back to the drawing board for that. And then while we were rebuilding the Steam VR driver, we also built in support for Monado, which is an open source runtime on Linux, as well as some basic OpenXR foundations. So essentially, what that means is we'll be able to support Steam VR's OpenXR runtime once it becomes finalized, which will make future integration with VR and AR apps much easier. So if you're unfamiliar with OpenXR, just a brief description of OpenXR is that it is uh, a cross-platform standard from Kronos Group that essentially provides a cross-platform API for programs and devices to communicate to each other. So just because currently, if you target an app specifically for, say, Oculus, it'll only work on Oculus. If you target it for Steam VR, it'll work on both because Oculus has a Steam VR support. But with OpenXR, if you target OpenXR, it'll support any runtime that supports OpenXR, whether that be Windows Mixed Reality, Steam VR, Oculus runtime, or Monado on Linux. So that's very exciting for device support and for developer support to sort of lessen the burden on supporting all these different devices. Uh, and I'll also mention that the HoloLens 2 currently runs on OpenXR as well. Um, so with that, we've also been, as I mentioned before, working with Esky for the lower level API, which is all the underload stuff, and then an upper level Unity SDK. We're currently working on an Unreal SDK specifically for that, as well as a configurator to help you get started with your headset calibration and any other modifications you'd make to your headset. So essentially, the idea is we want to make it as easy as possible to mod Project Northstar and turn it into something that's individualized, and you wouldn't have to worry about moving, say, the Leap Motion controller or the 6 degrees of freedom sensors that you use in there. So we want to give you guys generally a freedom with um, moving those devices around and then being able to use a software kit to configure all that. And then we're also in the preliminary discussion phase for Godot support for Esky as well, which will be exciting. So Godot is also an open source game engine, which is pretty cool. So eventually we'll have a completely open source um, stack for Northstar to run on, which will be exciting. And then of course, probably some of the most exciting stuff for me, at least, is hardware. So again, here's a little timeline of what we've done so far. So there was the original Leap Motion release. A few months after that, there was Leap Motion release version 3, which added a lot of different features that the community requested, namely support for glasses with adjustable headgear, 25 and 75 centimeter focal trays, which allows you to push the focal distance of the headset away from you or closer to you. We added a 3D calibration stand for the headset to actually be optically calibrated. Prior to this, this was very early days. We actually had to manually calibrate the headset with different points, which wasn't very reliable. So that was the start of the 3D calibration method. And then shortly after that, so not shortly, but after that, so Noah Zirkin and Smart Prototyping formed a company specifically for Northstar called Combined Reality. And they came out with the Deck X variant of the headset, which has a bit more streamlined design ready for injection molding, as well as an embedded T261 sensor that you can include with it that makes the headset generally more compact, as we went over a bit earlier. It also compacted the optics bracket a bit and made a bunch of 3D printing modifications. And then upcoming early 2021, around that time, there will be a Kickstarter for the injection molded headset, which will have a new driver board. It'll support direct mode on Windows, which is a big deal. It'll have integrated 3.5 millimeter audio, built-in USB hubs, USB 2.0 at least for now. And it'll also have the option to come with a wearable compute pack, which is pretty cool. So it'll be around a 4-inch by 4-inch by roughly 2 or so inch. We're still finalizing the design on that. Ryzen compute pack. So AMD Ryzen will be the core of this, and it'll be really cool to have a full embedded x86 computer to not only have as a wearable but also as a dev PC. So one of the things with a lot of headsets right now is they come with they either run on mobile chips like Qualcomm's XR2 or Snapdragon chips. And unfortunately, you can't run a lot of the development tools on those, like Unreal Engine, Unity, Visual Studio, things like that. So what's really cool about this is, since it's essentially just a small, x86 actual like laptop chip that we're running, it will allow you guys to actually develop directly on Northstar. So it's an investment you can make without having to worry about not being able to use it for something else. So if you wanted to buy the compute pack and the headset, and then later on you wanted to just use the computer for something else, even just to watch, things like YouTube or something like that, or just use it as a regular desktop, you could definitely do that, which is really exciting. So that's one of the things we've been pushing for, is the additions we want to make to Northstar is not only just for Northstar, but things that can be cross-platform and used for different projects. So it's pretty exciting. Hey everyone. So today I'm going to be showing you how to do some Northstar stuff. It'll be cool. So step 1, put it on the headset. So this is a Northstar Deck X headset. So the difference between this and the original version is the inclusion of the T261 sensor, which is located here on the top. You can see the 2 circles there. Now that's on top of the Leap Motion sensor, so that's what gives us hand tracking. The T261 sensor in here gives us positional tracking, and it's the embedded version, so it's much more compact than the T265 sensor, which is the module you'd buy if you're going to snap it on a robot or whatever. So this is the original T265 sensor here. So you can see it has like a full, USB 3 extension cable. You got, 4 cables hanging off the back of it. It's much more bulky than the Deck X headset. Still great, but less cables is better. So I'm just going to set this back down on my stand here, and with the just to go back to the Deck X headset here, You can see it's much more compact. The Leap motion sensor on this version is also pushed down further to make the overall headsets lighter. And then we've also added on some buttons on the top. Now these buttons are intended to be used for eye relief, so that way you can adjust IPD on the fly when you're giving it to multiple users. But they are just regular buttons, so you can program them to do anything you want, whether it be fire a laser, draw a grid in space, whatever you can think of, these buttons can do. So those are the two primary differences. You can also see that there's only two cables here. So the DeckX has an integrator board, which allows the headset to essentially combine power delivery and data into a single cable rather than splitting them out per sensor. So essentially, it's a USB and USB hub and power delivery management that also has an Arduino built in. So like I said, with those buttons, you can also do some really cool things with electronics as well, like integrating RGB LEDs and some other really interesting techniques. So what I'm going to do here is I'm actually going to put on the headset. I don't have a way of showing the view through the lenses currently. But what I can do is, because these are parabolic reflectors, it'll actually allow you to see the majority of what I see in the headset. So I'll be demoing a version of Leap Paint, which is similar to Tilt Brush, just so you can get an idea of the fluidity of the hand tracking and everything with this headset and sort of the visual quality. Again, it's not a through the lens demo. We'll have a few more of those integrated into this talk, but this will give you an idea of like what the headset's actually like. And what's really cool about this, when we were demoing this during the MIT Reality Hack, is it actually gives me, as a developer, an easy way to see exactly what the users are seeing, which is not really something you can get with the HoloLens or the Magic Leap. So in terms of testing the device, this is a really great way of doing that. So I'm going to go ahead and launch the app here. You can see I have my virtual hand there. You can see it on the display and also in the reflector there. You may notice that in this particular instance, it's not matching up perfectly with my hand, and that's just because this headset's actually a prototype, so I haven't gotten everything squared away here. We'll talk about calibration and everything like that in a bit later. So you can see here, I'm going to pick a color, and it's a bit difficult to see just because of the contrast of the camera here. But the brightness of this headset's actually really great. Like even looking at a computer monitor, I can still see clearly all of the paint palette and the buttons here and my virtual hands as well, which is something that a lot of other headsets struggle with. So you can see here what I'm going to do is I'm going to go ahead and start drawing here. So there, you can see there I did a circle. I'll write hi inside of the circle, so you can really see the fidelity of the hand tracking is really incredible. So this is using the ultraleap hand tracking. I'll try to get a bit better of a screen view there. And you can see that I can move around the object too. So that's what the T261 is doing. To give you a better example of that, what I'll do is I'll actually move back further from it and draw something around it. So I'm going to pick a purple color here and just draw a purple line there. So you can see that's much bigger. And what I can actually do is I can actually move around it, and you can see the image updating my headset. So this is what gives you that 3D effect. So it's the combination of the stereo overlap from the displays and also the T261 positional tracking. You can run the headset without a positional tracker, but then you're limited to just the DOF from the hand. So anything you draw or create in the application would move around with you. Now, there have been a few users who have actually just hooked up a 3DOF IMU to the headset instead of the positional tracker, which saves them a bit on cost. So that would give you a bit more of an experience like an Oculus Go headset, where you don't have that 6 degrees of freedom. But what's great about this is this works very similar to the Windows Mixed Reality headset, so there's no external tracking you need to set up. However, like mentioned previously, you can actually set this up with a Vive tracker or a similar Steam VR Lighthouse tracking mechanism, which will allow you to use that infrastructure for 6DOF tracking. So if you've already got a Vive and already have Lighthouses, that might be a cheaper method for you. Now we've also got SDK support for the Z Mini coming for our Steam VR drivers. So we'll have the Z Mini tracker there. So if you happen to already own one of those, we'll have 6DOF support for that as well. And the nice thing about the Z, even though it's limited to just NVIDIA cards, it does allow you to have some spatial mapping and meshing techniques, which this solution currently does not, but we are working on integrating some of that. I'm just undoing some of my drawings here so you can see it's all gone. And what's really great about this headset is the time to development. So unlike the HoloLens or Magic Leap, you don't have to deploy to a device. You can just click build or click play in Unity and it'll automatically pop up on the device just like another Steam VR headset, which is pretty great. So as far as Steam VR is concerned, it thinks this is a VR headset. Steam VR doesn't have any AR calibrations to it. What makes this AR is by having the images not have a bright background. So here I'm showcasing the demo CAD Explorer. So you can see here the demo is running directly on this headset. And you can see on the screen here how it looks in VR. Now, if you were going to convert this into an AR app, it's pretty easy. The only thing you'd have to do is make the background dark. But you can see that it's still running perfectly fine, even though the background is super bright, right? So if I were to turn all the lights off in this room, it would actually work directly as a VR app. And one of the things that's really cool about the northstar headset is that the displays are bright enough to where I can still see my computer monitor and everything, but the image isn't too washed out. So if I want to prototype a VR app without having to like put on a headset that occludes my vision, I can't see my computer anymore. And if I want to do some like live coding or something like that, I'm actually able to develop a app while still seeing the rest of my environment, which is pretty great. So just a quick little disclaimer here. So the footage you're seeing through the lens or through the reflector is filmed with my iPhone, and it's only showing one portion of one eye, so one side of the reflector. So it's not exactly completely indicative of the field of view that you'd get through a northstar headset. But I did want to show you guys at least a bit of the visual quality you can get. So what's really cool here and what's to take note of is the fact that you can see the cat, even though my monitor is on full brightness right behind it. So like all of the 3D objects are all visible. That's sort of the main point of the through the reflector footage. So thanks for coming to my Global XR Bootcamp talk on Project Northstar and open source augmented reality. I had a lot of fun making it, and I just wanted to say thanks to the team who put this event together. It's pretty cool to see something like this during the state of the world. So pretty awesome. Glad I could contribute. And if you have any questions that I don't end up getting to during the Q&A, definitely check out the Project Northstar Discord server, and there'll be an invite link for that in the video description. So thanks for watching. Hey everyone, how's it going? So it doesn't look like I have a moderator here yet, so I guess I could show some more demos. Hi. Sorry about that. I didn't really.
Just takes a while to set things up. All right.
Okay, cool.
I can still show you. Oh, no, we can't. Sorry. Like this. Okay.
Okay.
And I'm going to turn on my camera if I can. Yep, here we go. Hi. So that was an awesome talk, and it's nice to meet you in person.
Yeah. And so it's nice to meet you too. Looks like we've got a first question there. So to answer that, if you want to go ahead and put them on there. Yeah.
Simon Frubis, is there anyone in Berlin who has one would love to connect and test it? So yeah, how wide is your community?
We're global, just like the boot camp here. So the Northstar Discord has people from all over the world. So our manufacturing for the electronics and stuff is based in Shenzhen. So we've got a few people from China. We've got a lot of people from the States, like West Coast, East Coast, Midwest, a few people from Texas. We've definitely got a lot of people from Germany. So there are a few XR developers specifically from Germany there. I don't know if we have anyone directly from Berlin, but the best place to find it out would be on the Northstar Discord. So I posted a link in the YouTube chat there, but I'll see if we can get this added to the YouTube description as well. It'd probably be helpful. Yeah, that's definitely the best place to check it out. Would be the northstar Discord. So
Right, that's awesome. Okay. Um, I'm not even gonna try and pronounce. But Kim is asking you, hey Brian, I think you mentioned the headset you're using now is a prototype. Apologies if you've already mentioned it, but when is it being released, and what is the name of the headset?
so the name of this headset in particular, so this blue one I was showing off during the demo, is called the Combined Reality Deck X headset. This is a modified version of the original open source design for Project Northstar. So if you're just Googling for things, Project Northstar is usually the best term. If you're looking to order a kit, you can go to combinedreality.com for that, and that's where you can get all your hardware for it. Right now, pre-assembled kits aren't being sold yet. We're trying to shoot for around 2021 to start a Kickstarter for some injection molded headsets that'll be pre-built and pre-assembled. But if you want to get into it like today, you'll want to 3D print it, which is all on the GitHub. So you can go to github.com/project or /leapmotion/project Northstar, and you'll find all the files there.
Okay, I hope that helps. So yeah, while we're waiting for more questions, I have a couple. So you mentioned that this whole headset is open source.
Yeah.
And that's pretty strange for a software guy like me to have open source hardware.
Right.
But can you tell me some examples of some community contributions?
Sure.
So what kind of contributions the community, just people coming out of blue?
Yeah. So I can actually show you something we're actually working on right now. So I mentioned a little bit in the video about calibration and how because the headset's 3D printed, each headset is going to have uniquenesses to it that would need to be compensated for. So some of the stuff that we've come up with as a community is a lot of methods towards making that easier. So the original calibration method that Leap Motion ended up shipping with the headset required a dual stereo camera, which was something like this. So in this case, each one of these cameras is about $80. And then you'd have to point the headset at another monitor. So then people would have to first acquire these from somewhere, build a calibration stand for it, point the camera at their headset at another additional monitor, and then calculate some stuff. And that process took forever, and it was really time consuming. So we ended up coming up with a community, as the demonstration I showed in the talk, where we had a new method of calibration that just requires the stereo camera that we're already using for 6 degrees of freedom, which is, better for people because they don't have to buy extra stuff. So it's always good when you don't have to buy extra things.
So how much would it cost me if I wanted to have a headset like this?
So this one right now, you can buy the parts. So just the electronics for the headset and the optics. So this is not including the Leap Motion controller or the Intel sensor. Cost around $350 currently. And then if you want to buy the Intel or the Intel RealSense and the Leap Motion controller, I would recommend for Leap Motion, go to eBay. Yep. You can find them cheaper there for sure. I've snagged a few for like $20, which is pretty great. And then for the Intel sensor, we sell that on through Combined Reality as well. So you can buy that for around $99. So in total, the headset should come to around $500 to $600 currently. And once we get the Kickstarter going, we'll be able to do some economies of scale there and get the prices down further. But right now, we're pretty much selling the parts for a little bit above the cost of them, just to get some margins in there to continue R&D development.
Right. Well, that's absolutely understandable, and no shame in it at all. Okay, Simon's back. There's another question, but he loves your enthusiasm. So.
Yeah, no, it's good to be enthusiastic about this stuff.
It is.
I started doing Northstar because I couldn't afford a HoloLens. Like, I was watching the HoloLens 2 announcement, and I'm like, it's going to be cheaper, right? And then they did. I don't think they released the price of that during that announcement talk. But $3,500 is
Yeah.
definitely more than I was expecting to spend. And so the original headset I actually built before we were able to source screens and everything. So this is my first one I built. So this is the guts of a Samsung Odyssey headset that I disassembled because it was broken. So I bought it off eBay for cheap, right? Because it was defective. Turns out they had scratched the lens, which I don't need. So I disassembled the whole thing and rebuilt it into a Northstar headset.
So you're using the display from that.
Yeah, so this is a sort of hard to show over webcam, but this is actually an OLED display in the sky, which is cool. So the current Northstar displays are actually much better though. So they're the same ones used in the Valve Index. So essentially, like the brightness and refresh rate are pretty much unparalleled right now. Looks like we've got another question from Simon.
Yeah, let me. Yeah. Kim was next.
Oh, okay.
Do you have any? Thanks for the detailed answer. Do you have any recommendations for a 3D printer?
Sure. So a lot of people on the Northstar Discord recommend the Creality Ender 3. You can get it for around $200 or so, and there's a link for it in the on the GitHub as well. We have a full documentation page and everything like that. But if you're just getting started with 3D printing and don't want to spend a lot of money, that's a good place to start. And then the Creality, I believe it's called the Creality 6 Pro SE just came out, which is a really reliable 3D printer. So we're looking at using that for distributing manufacturing across the world, which will be pretty cool. So if people don't have access to 3D printers, we're going to try to spin up manufacturing the parts locally, so we don't have to ship them crazy distances.
We are really living in the future.
Yeah.
And yeah, Simon is asking about the Kickstarter. When will the Kickstarter start?
So we're going to try to shoot for early 2021 for that. We don't have any tentative dates yet, just because the state of the world is kind of crazy at the moment. We've tried to, we were like originally shooting for a few months ago, and that was pre-COVID, so that didn't happen. But it's definitely, we're still moving along with it. We just want to make sure that when we do a Kickstarter, it's something that's like we know we're going to be able to deliver. We've got the logistics sorted out. We've got some new software and everything ready to go. Because the last thing I want to do is to have everyone get a headset and then be like, oh, there's no demos for you to try out. Or we're still working on that SDK. So we're trying to, make everything as easy to assemble and build right now for yourself if you want to jump into it. But the Kickstarter will probably come into around 2021. We'll shoot for the early part of that year. So, which is coming very soon, which is nerve-wracking.
Far away. Yeah. So how did you get into this whole Northstar thing?
Sure. So originally, Leap Motion was the company that originally open sourced the headset. So they did the original R&D for it and everything. And I saw their blog post after looking at some hand tracking stuff that I was working on. And I was like, wow, that's really cool. And just so happens my company had a 3D printer in our snack room that no one was using. I was like, hey guys, can I use the 3D printer? And no one responded, so then I just took it. I was like, this is mine now, my 3D printer. So I started learning how to 3D print on that, printed out my first headset. But it was a good challenge because for a while, when I first started, we didn't have the display sourced or anything. And display companies don't talk to you if you're just some guy from the internet, right? Like if you go up to these manufacturers like BOE or Samsung, and you're like, hi, I'm a hobbyist on the internet. I would like your expensive display, please. And I just wanted one of them. And they're like, can you buy 30,000, please? So, for a while it was like, okay, how can we get these displays? I ended up ordering a set off of like Alibaba of some 2.9-inch displays, which were like not as good. And the driver board was wonky. And I had like 5 cables coming out of my headset. And then Noah Zirkin, who is one of the lead people at Smart Prototyping, was sort of working on getting the reflectors manufactured, because originally those either required 3D printing with resin or CNC machines. So like this is one of the original lenses I had printed in resin. So you can see there's like a lot of artifacts from sanding. The optical quality is not very good.
Image
And I
quality.
have, so we've been through a few different revisions of Reflector. So this is one of the first ones from the factory that Noah worked on. So you can see it's very transparent, which means the image wasn't as bright. And then since then, we've actually figured out some different coding methods. So it's not only about manufacturing just the polycarbonate reflector. You also have to code it, which is a whole other process. So you can see this one here is much more bright, much more reflective. So you can see it like reflecting my computer monitor there. So this really improves the image quality on the headset itself. So it's definitely been a journey. Lots of prototyping and fun and building. But it's definitely a learning experience. So if you're like looking to learn how to do all this stuff and like how a HoloLens works or how does an XR headset actually talk to a computer, like Northstar is where to be. One of the things I've been trying to do as like a personal goal is like, you can't learn this stuff normally, right? Like Microsoft have like 1,700 people just working on the HoloLens 2, right?
Yeah.
So, where are you going to learn about like how to build a compositor like Steam VR for a headset, right? Or how to get a headset to communicate with that kind of thing. Like there's no tutorials at all. So, I want
is it your full-time job right now?
No, I do all of my Northstar stuff on the side. So my full-time job is at a marketing and technology company where I build a lot of Unreal Engine demos and do some 3D renderings and stuff. So I'm a 3D artist by trade, architect by training, and Northstar dev by night.
Yeah. How do you sleep?
Pretty well, surprisingly.
Right. That's good. Simon has another question. Thought you studied architecture. How come that you switched to tech? Interesting shift. Reminds me of Matt Schaefer, who works now at Facebook as VR product designer.
So one of the cool, that's a question, right? So one of the cool things about architecture in general is that it's very tech driven, right? Like right now, if you were to design a building, you can sketch it on pen and paper, but everything eventually has to go through a computer of some kind. So I was sitting in college one day, and to create like images of my designs and everything, you had to click render, right? So you have to send them to like a render farmer or render them on your laptop, which will be really slow. It'll take forever. And I was sitting there like 2 hours waiting for this thing to go. And I was playing Minecraft, right? And I'm like, wait a second. So Minecraft gives me like 60 frames per second. And this rendering is one image per 2 hours. So how can I like turn my building into a game, right? So then I was like looking at game engines and stuff. And this was like right after Unreal Engine became free to use. So I popped up Unreal Engine. I figured out how to import one of my building files into Unreal. And then conveniently right around the same time, one of my professors recommended me to a friend of his who was just getting started into doing VR for his company. So, I got the interview there got a job as an intern, and all of a sudden I was working on VR, which was nuts. So they're like, hey, we don't have time to spend on this, but it's an R&D thing we want to do. Here's Unreal, here's some Vive controllers, go wild. And I spent about 2 weeks trying to get the Vive controllers to hook into Unreal before VR support was officially added. And I'm like going in, I'm like every morning, I'm like, oh man, am I going to be able to do it today? Because I was like, this was while I was in college. So like I had never done it before. I was like, I've seen some YouTube videos. There's not much out there. VR is still new. So I'm like still going through. I'm like, 2 weeks in, I'm like, finally, I get the controllers to show up in the engine. And I'm like, yes, I did it. Victory.
That was feel awesome.
Yeah.
And, Simon is asking exactly that. How does it feel to be part of this moonshot project that will shape our future?
Yeah, I mean, I really hope it will shape the future. It's really concerning seeing what Facebook is currently doing with the Quest, with the
Right.
like mandated Facebook login. You don't know what they're collecting with their privacy policy. Like they literally left it open for them to collect whatever they want.
Yep.
And on top of that, like you've got this headset with 4 cameras. It's got your motion data. It knows how far apart your eyes are. It knows like generally like where you're looking. You know, with these technologies, like if you're doing like eventually like VR web browsers are going to have ads in them, and ad tracking right now is already really pervasive. So imagine that when they can like actually see exactly which ad you're looking at and for how long. So what I'm hoping with Northstar is that it provides an open framework and enough of a foundation to start building more compact designs and actually, eventually get to that point with glasses. But and this is sort of segueing into the panel we're going to have next, which is the future of XR. But it is really interesting seeing these mega tech companies, like even Apple with their recent new MacBook launch with the M1 chips, seeing how efficient and powerful they can make a 10-watt CPU. Like that kind of engineering is what's going to go into the next XR devices. And when you start looking at that level of scale, you're like, okay, how can we keep this buildable? If you like, and then it gets into right to repair and everything. So there are some times where like I get frustrated at things. I'm like, man, why can't this be like my iPhone, right? But it's helpful to take a step back and I usually just load up the paint demo and I just try that out for a bit to calm down. I'm like, okay, I'm just going to paint some things and like see how far we've come already from from this to this, just over 2 years, and just a bunch of people online collaborating. Like so far, there's only one person that actually gets paid for building Northstar headsets, and that's the guy who's sourcing all the hardware for us. So
that's Noah, right?
Yeah, that's Noah Zirkin. Yeah.
All right. So Simon again, we're chatting with Simon here, and we got 3 more minutes. Thanks for the inspiring answer. And one more question from him. What are the 1 to 3 most important USPs from Northstar compared to other headsets?
So I'm going to assume that means universal selling point. I'm not entirely sure. But as far as advantages,
because
I don't. But I'm just going to assume he means like advantages to Northstar. So one is cost, right? Like a Magic Leap is 2100, I think, or 21 to 2500. If you wear glasses, you pretty much can't use a Magic Leap without their special insert. HoloLens 2, $3,500. Northstar, you're getting it around $500 to $600, depending on how thrifty you can be with eBay. And there are cheaper versions as well. So if like you're really strapped for cash, you can build a $200 version of Northstar, which will have some lower specs, but it'll still work, which is pretty cool. But I'd say the best, like from a developer standpoint, the thing that makes me happy about it is I can just click run, and I don't have to deploy to anything. I don't have to worry about like deploying to my Magic Leap device or plugging that in and sending the build to that, doing a build process and going through. I can just click preview in Unity or in Unreal, and just have it immediately on the headset. So the time
actually you can do remoting with the HoloLens and the Magic Leap as well. So basically press play, but obviously the real application is going to have different performance and whatnot.
Right.
But I can imagine that, and using your PC's resources and power, that's really awesome. And is there anything like a wireless?
So wireless is really
version
hard
on the roadmap somewhere.
So one of the things we're working on is a compute pack. So this is a 4-inch by 4-inch AMD Ryzen compute pack, so pretty small. This is a prototype. The Kickstarter one will be slimmer, markedly thinner, because we're ditching the Ethernet ports and stuff.
Right.
But this will essentially act as a Magic Leap power pack. So it won't be wireless in the form of a HoloLens where everything's built into the headset, but it will be wireless, more like a Magic Leap, where you have a computer.
What I meant was wireless connection to the PC.
Okay, yeah, that's really hard to do.
Yeah.
I'd say as soon as Valve release one for the Index headset, we'll have wireless on Northstar, because it's the same resolution and everything. So as soon as that becomes a possibility, we'll probably be able to do that on Northstar as well. So
that's awesome. That's awesome. All right, so I think that's all the time we had, and thank you for your passion and all of this, the great talk that you gave. It was really nice to talk to you. It was really nice to meet you, and
it's nice meeting you as well.
Let's keep in touch. I hope everybody liked this. This was Brian Brown, and goodbye. Thanks.